So, when we're talking about CRUM and how CRUM models the mind, there are 6 approaches: logic, rules, concepts, analogies, images, and neural connections. We already started talking about logic. We talked about how logic is actually rather old, starting with Aristotle, that it has a lot of representational power when it comes to how the mind works as well as computation. And we gave an example. All students are overworked. Mary is a student, therefore Mary is overworked. It's all very logical, right? Makes perfect sense? Well, I have some logic tasks for you, where I'm going to actually ask you to use your logical capabilities. Now, there's a task that's called Watson's selection task. And so we're going to go ahead and try this in class. Now, that means you have to talk. Someone does. So let's see what that is. Here you have 4 cards. Each card has a number on one side and a letter on the other side. And what you're going to do is you're going to test a logical statement against these cards. So what's the rule to be tested? If a card has an A on one side, then it has a 4 on the other side. All right, so I'll mention that one more time. If a card has an A on one side, then it has a 4 on the other side. I want you to think about that, because here's what you need to do. You need to tell me which cards must be turned over to determine whether that rule holds. Whether that rule holds for these. Yes?
Do you want to say answer louder?
Yes.
Only the A.
Okay, so we have one answer is only the A. Any card?
All 4.
All 4 cards. So we have, okay. So we have one person who says only the A.
The A and the 4.
We have someone who says the A and the 4. Someone who says all 4.
All 4 or the A and the 7.
And the A and the 7. No? A and 4. Okay, so let me see if let me summarize. So, and we'll vote. Is anyone still saying just the A? Okay, so just the A. Who thinks it's just the A? A couple of you. What was the other one? The A and the 4. All right, and maybe about a third of you think it's the A and the 4. What was the other one? The A and the 7. One person, and all 4. Okay, one person. All right, so let's see the answer. Keeping in mind, we are using logic. Well, we do have to turn over the A, right? Because the rule says if it has an A on one side, it must have a 4 on the other. So we do have to turn over the A. That is basically the rule of modus ponens. If A, then 4. If P, then Q. P, therefore 4. And there was one person who was right. We also must turn over the 7. Why is that?
Because if the 7 had an A on the other side, then the rule would be broken.
Right, so if the 7 has an A on the other side, then our rule is broken. Yes?
The rule doesn't state that it can only have a 4 on the A. It just says that if there is an A, there has to be a 4 on the other side. So not that it only has to have a 4. It could also have a 7 that wouldn't refute the rule.
Well, no, if the A had the 7, then it would refute the rule, because the A must have a 4.
Right.
Yeah, but it doesn't say that it can't have anything else. It can have a 4.
But it must have a 4.
Yeah, it says it must have a 4.
It can only be a 4.
That it can only be a 4. So if it has an A, it must have a 4. Right? So we do have to turn over 7. So that's modus tollens. If A, then 4. 7 means not 4. So not A is required for the rule to hold. If P, then Q, not Q, therefore not P. Turning over B is irrelevant. Anyone know why? Not part of the rule. Turning over the 4 is irrelevant. That's a tougher one. Anyone know why?
It didn't say that A is the only one that has 4, B can have a 4, C can have a 4. It only says that the A must have a 4.
That's correct. It says A must have a 4. It didn't say that a 4 has to have an A. It can have a B or a C or so forth. That's a tough question. So, are you feeling dumb? Yeah, I'm going to tell you, don't feel dumb. Because I will tell you that I have had classes where no one got it right. Because it's tough. But one thing about Watson's selection task is that we can actually improve how well we do if we take into consideration how we work as humans. So, if you put it into a context that we are familiar with, now all of a sudden it becomes a lot easier to figure out. So, now we're going to change our cards a little bit. I want you to suppose that the cards have information about whether individuals are in a bar on one side, right? So in a bar or not in a bar. And the numbers on the other side indicate how old they are. Something we're more familiar with, right? Especially at your age, you're trying to figure out, can I get into that bar? Are you legal or not? So we think about this a lot. So here's the rule to be tested. If a person is in the bar, then he or she is 21 years of age or older. Now, what cards do we need to turn over?
In bar and 18.
Okay, in bar and 18. Everyone agree? It was a lot easier, wasn't it? Now you feel brilliant. So, again, this is an example of how context and how experience influences how we think as humans. So we want to make sure that we think about this in our design. You're not just designing an interface for a computer. Well, sometimes you may be, but if you're designing something for humans, we want to think like humans. It makes a big difference in what we find really natural and easy to do and what things can be more difficult.